Stars. We all have the general idea of what stars are, but how are stars born? How do they die? Well, stars are hot bodies of glowing gas and dust and contract under their own gravity. Nuclear reactions at the center or core of stars provide enough energy to make them shine brightly for many years. This is what illuminates our night sky. The color of a star is determined by its temperature. The hottest stars are blue and the coolest stars are red. The sun has a surface temperature of 5,500 degrees Celsius, and its color appears yellow. Eventually, however, the hydrogen fuel that powers the nuclear reactions within stars will begin to run out, and they will enter the final phase of their lifetimes. The path they follow beyond that depends solely on the mass of the star. Let's start from the beginning. Stars originally form in high-density nebulae, massive clouds of gas and dust. The exact lifetime of a star depends very much on its size. Very large, massive stars burn their fuel much faster than smaller stars, and may only last a few 100,000 years. Smaller stars, however, will last for several billion years because they burn their fuel much more slowly. A star now begins a new life. Here, a region of condensing matter will begin to heat up and start to glow, forming protostars. This is the first stage of a star's life. If a protostar contains enough matter, the central temperature reaches 15 million degrees centigrade. At this temperature, nuclear reactions in which hydrogen fuses to form helium can start. The star begins to release energy, stopping it from contracting even more and causing it to shine. It is now a main sequence star. A star of one solar mass remains in main sequence for about 10 billion years, until all the hydrogen has fused to form helium. The helium core now starts to contract further, and reactions begin to occur in the shell around the core. The core is hot enough for the helium to fuse to form carbon. The outer layers begin to expand, cool, and shine less brightly. The expanding star is now called a red giant. In supergiants, nuclear reactions occur, forming different elements and shells around the iron core. These stars start off with a helium core surrounded by a shell of cooling, expanding gas. For stars of less mass, the helium core runs out, and the outer layer drifts away from the core as a gaseous shell. This gas that surrounds the core is called a planetary nebula. The remaining core, about 80% of the original star, is now in its final stages. The core becomes a white dwarf. The star eventually cools and dims. When it stops shining, the now dead star is called a black dwarf. Regarding our supergiants again, at this stage, the core collapses in less than a second, causing an explosion called a supernova, in which a shockwave blows out the outer layers of the star. The actual supernova shines brighter than the entire galaxy for a short time. Sometimes the core survives the explosion. If the surviving core is between 1.5 and 3 solar masses, it contracts to become a very tiny, very dense neutron star. If the core is much greater than 3 solar masses, the core contracts to become a black hole, a region of space having a gravitational field so intense that no matter or radiation can escape. This has been the life of a star. Pulsars are types of neutron stars, the dead relics of massive stars. What sets pulsars apart from regular neutron stars is that they're highly magnetized and rotating at enormous speeds. Astronomers detect them by the radio pulses they emit at regular intervals of up to 1,000 pulses per second. Pulsars spin because the stars from which they formed also rotate, and the collapse of the stellar material will naturally increase the pulsar's rotation speed. Scientists think millisecond pulsars must have formed by stealing energy from a companion. The pulsar siphons matter and momentum from its companion, gradually increasing the spin rate of the pulsar. This is bad news for the companion star, which may be completely devoured by the pulsar. Following the other path a postmortem star can take, a quasar is believed to be a supermassive black hole surrounded by an accretion disk. The quasar gradually attracts stellar gases and sometimes other stars or even small galaxies with their super strong gravity. When a galaxy, star or gas is absorbed in the quasar in such a way, the result is a massive collision of matter that causes a gigantic explosive output of radiation energy and light. This great burst of energy results in a flare, which is a distinct characteristic of quasars. Stars are a fascinating component of our universe. They may seem like permanent objects in the sky, but technology has allowed us to photograph the heavens, and now we know more about the stars than ever before. I'm Chase Ralston, and thank you for watching Stellar Evolution.